I'll investigate how the concentration of vinegar affects its reaction with baking soda using simple household materials. The aim is to investigate how changing the concentration of vinegar affects the rate of reaction between vinegar and baking soda. Concentration is one of the four main factors that affect reaction rate, along with temperature, surface area, and catalysts. In this investigation, concentration is the only factor that will be changed, allowing me to investigate its effect on the rate of reaction. Vinegar contains acetic acid, while baking soda is sodium hydrogen carbonate. When these two substances react, they produce sodium acetate, water, and carbon dioxide gas. As the carbon dioxide gas is produced, it cannot escape because it is trapped inside the balloon. As more carbon dioxide is produced, the balloon inflates. This means that the speed at which the balloon inflates can be used as an indirect measure of the rate of reaction. But why should concentration affect the rate of reaction at all? Concentration refers to the number of reacting particles in a given volume of solution. In a dilute solution, there are fewer acid particles in the same volume. In a concentrated solution, there are many more acid particles packed into that same space. This difference in particle density plays an important role in determining how quickly a reaction occurs. To carry out this investigation, I used vinegar, water, baking soda, 4 identical plastic bottles, 4 identical balloons, a measuring cup, measuring spoon, funnel, stopwatch, and a ruler or caliper. Using identical bottles and balloons helps us to make this investigation as fair as possible. The independent variable is the concentration of vinegar because this is the factor that I am deliberately changing. The dependent variable is the time taken for the balloon to reach a fixed circumference because this is what I will measure. To ensure a fair test, several variables must remain constant. The mass of baking soda will remain the same because changing the amount of baking soda would also affect the amount of carbon dioxide produced. The total volume of each solution will be kept at 100 milliliters so that only the concentration changes. The same bottle size, balloon type, and room temperature will also be maintained throughout the investigation to improve the validity of the results. My hypothesis is that increasing the concentration of vinegar will increase the rate of reaction. This is because a higher concentration contains more acid particles in the same volume, increasing the frequency of successful collisions between reacting particles. As a result, carbon dioxide will be produced more quickly and the balloon should inflate in a shorter amount of time. Now that the investigation has been planned and all the variables have been identified, it's time to carry out the experiment and collect the data. To investigate the effect of concentration, I prepared 4 vinegar solutions keeping the total volume constant at 100 milliliters. Bottle A contained 25 milliliters of vinegar and 75 milliliters of water. Bottle B contained equal amounts of vinegar and water. Bottle C contained 75 milliliters of vinegar and 25 milliliters of water. Finally, bottle D contained pure vinegar with no added water. Keeping the total volume constant ensures that concentration is the only variable changing, making this a fair test. Next, I measured 1 tablespoon of baking soda into each balloon using a funnel. Using the same amount of baking soda in every trial keeps the mass of the reactant constant, ensuring that any difference in reaction rate is caused only by the vinegar concentration. I carefully attached each balloon to its bottle without allowing the baking soda to fall into the vinegar. This ensured that every reaction started under the same conditions. Once everything was ready, I lifted the balloon so that the baking soda fell into the vinegar solution. At exactly the same moment, I started the stopwatch. As the reaction began, carbon dioxide was produced, causing the balloon to inflate. I stopped the timer once the balloon reached a fixed diameter of 15 centimeters. To make the differences easier to compare, the reactions are shown side by side. Even before analyzing the data, it is clear that the balloons inflate at different speeds. The higher concentration solutions appear to react much more vigorously than the dilute solutions. The 25% vinegar solution was the limiting reagent, so there was not enough acetic acid to react with all the baking soda. This produced insufficient carbon dioxide to inflate the balloon to 15 centimeters. During the investigation, I made both qualitative and quantitative observations. Qualitatively, all 4 bottles produced bubbles and foam as carbon dioxide gas was released. However, there were noticeable differences in the intensity of the reaction. The 25% vinegar solution produced gentle bubbling and slow balloon inflation. As the concentration increased, the bubbling became more vigorous, more foam was produced, and the balloons inflated more rapidly, as the 100% vinegar solution showed the fastest and most vigorous reaction. To improve the reliability of my investigation, I repeated each experiment 3 times and calculated an average time. Repeating experiments helps reduce the effect of random errors and increases accuracy in the final results. After completing 3 trials for each vinegar concentration, I calculated the average time taken for the balloon to reach a fixed circumference of 15 centimeters. Using the average rather than a single result improves the reliability of my investigation because it reduces the effect of random errors. These results were then plotted into a graph. This graph clearly shows the relationship between vinegar concentration and the time taken for the balloon to inflate. As the concentration of vinegar increased, the time taken decreased. Since the balloon always inflated to the same size before the timer was stopped, a shorter time means the carbon dioxide was produced more quickly. Therefore, increasing the concentration increased the rate of reaction. This graph shows a clear negative correlation between concentration and reaction time. But why did the concentrated solutions react so much faster? To answer that, we need to look at the reaction on a microscopic level using collision theory. Collision theory states that chemical reactions only occur when reacting particles collide with enough energy and in the correct orientation. In the dilute vinegar solution, there are relatively few acid particles in the same volume. As a result, there are fewer successful collisions each second. This means carbon dioxide is produced more slowly, so the balloon inflates more slowly. In the concentrated vinegar solution, many more acid particles are packed into exactly the same volume. This means particles collide much more frequently. As a result, the number of successful collisions each second increases significantly. Carbon dioxide is produced much faster, causing the balloon to inflate more quickly. This explains why the 100% vinegar solution had the fastest reaction rate. However, it is important to remember that increasing concentration does not increase the energy of the particles. Instead, it increases how often particles collide. Because there are more collisions every second, there are also more successful collisions every second, which increases the rate of reaction. Now I will evaluate the investigation and discuss how it could be improved. Overall, this investigation successfully demonstrated the effect of concentration on the rate of reaction. The results followed a clear trend that supported my hypothesis. However, like all scientific investigations, there were some limitations that may have affected the accuracy of my results. One limitation was human reaction time when starting and stopping the stopwatch, which may have introduced small timing errors. Another limitation was that balloons are not perfectly identical. Small differences in elasticity may have affected how quickly each balloon expanded. It was also difficult to release the baking soda at exactly the same moment for every trial. Finally, although the investigation was carried out indoors, slight changes in room temperature may have also influenced the rate of reaction. To improve the reliability of my investigation, I repeated each concentration 3 times and calculated an average result. This reduced the effect of random errors and made my data more dependable. Accuracy was improved by measuring the vinegar and water carefully using the same measuring equipment each time. The investigation was valid because only one variable, the concentration of vinegar, was changed while all other important variables were kept constant. Although the investigation produced clear results, there are several ways it could be improved. Instead of using balloons, a gas syringe could be used to measure the volume of carbon dioxide more accurately. Conducting the experiment in a temperature-controlled environment would ensure that temperature does not influence the rate of reaction. Measuring the baking soda using a digital balance instead of a tablespoon would improve precision. Finally, repeating the experiment more times would further improve the reliability of the results. Throughout the investigation, appropriate safety precautions should be followed. Safety glasses should be worn to protect against accidental splashes. The experiment should be carried out in a well-ventilated area to prevent carbon dioxide from building up in a confined space. No chemical should be tasted or consumed, and hands should be washed thoroughly after completing the experiment. After the investigation, the remaining solution should be safely disposed of down the sink with plenty of water, minimizing any environmental impact. This investigation demonstrates how a simple experiment using everyday household materials can explain an important scientific principle. Understanding reaction rates is essential in many real-world situations, including the manufacture of medicines, food production, and industrial chemical processes, where controlling the speed of reaction is both economically and scientifically important, essential for producing safe, efficient, and high-quality products. In conclusion, this investigation successfully answered the research question, how does the concentration of vinegar affect the rate of reaction with baking soda? The results showed that increasing the concentration of vinegar increased the rate of reaction. The highest concentration produced the fastest reaction because it contained the greatest number of acid particles in the same volume. According to collision theory, this increased the frequency of successful collisions, allowing carbon dioxide to be produced more quickly and causing the balloon to inflate faster. Overall, my hypothesis was supported by both the qualitative observations and the quantitative data collected during the investigation. Thank you for watching my investigation.